Hello everyone. In this video series, we will be solving all the exercises of ML Aggarwal Class 11th CBSE. Now, chapter number 1 is numbers. We will start with exercise 1.1. Question number 1 is, what is the greatest prime number? We all know the prime numbers between 1 and 10 are 2, 3, 5, 7. So, the greatest prime number we have here is 7. Now, moving to the next question. The number 37 and 73 are prime numbers. Okay, both of these numbers have the same digit 3 and 7. Okay, find such pairs of prime number up to 100. Now, finding the prime numbers which should be like these prime numbers like 33 and 73, it means they have same digits. What are that? They are like C. We can say it is 13 and 31. After that we can say it can be 17 and 71 also, and after that we can say it can be 79 and 97. Now, moving to the next question we have here is, write 7 consecutive composite numbers between 1 and 100 so that there is no prime numbers between them. It means it should be consecutive like one after the another one. It means the numbers we have here are 90, 91, 92, 93, 94, 95, and then we will have 96. The next question we have here is, write all pairs of twin numbers between 40 and 100. Now, twin numbers are like one after the another one. So, the first twin numbers we have here is 41 and 43. After that we have 59, 61. Then we have here 71 and 73. These are the list of twin numbers between 40 and 100 which are prime numbers. Now, after that, the next question we have here is, which of the following pairs are co-prime? Okay, what are co-prime? Co-prime are those numbers which doesn't have any common factor other than 1. Now, we will find the factors for all. For 18, factors will be 2 into 3, 6, 3 is 18, and for 35 you can write 5 and 7 to 1 into 1. So, they both have no common factors, only one can be the common factor. Now, if they have no common factors, it means they are co-prime numbers. Now, moving to the next one, 15 and 37, how can you write? See, 15 can be written as 3 into 5 into 1, and 37 is a prime number, 37 into 1. So, we can say it is also co-prime because they have no common factors other than 1. Now, next question we have here is 81 and 16. For 16 we can write 2, 2s are 4, 2s are 8, 2s are 16 into 1. For 81 we can write 3, 3s are 9, 3s are 27, 3s are 81 into 1. So, it is also co-prime because they have no common factors. Now, next question we have is 17 and 68. See, 17 is a prime number, 17 into 1, 68. For 68 we can write 17 into 4, 17 4s are 68 into 1. In this case, we have a common factor, that is 17. It means it is not a co-prime. It is not a co-prime because there is a common factor 17. Now, for this we can write for 215, we can say 5, 5 4s are 20 and 15 3s are, so 5 into 43, and then 216 you can write 2 into 108, again 2 into 54, again 2 into 27. So now we can say that there are no common factors. 27 you can write 3 into 9, but still there will be no common factors. So you can say it is a coprime. Now 30 and 415. Now 30 and 45, what are the factors of that? 30 can be written as 3 into 2, 6 into 5. Now for 415, we can write 5 into 5 8s are 40, 1583. 5 and 5 both are common. When there is one common factor other than 1, then it is not a coprime. It is not a coprime. Now moving to the next part. The next question we have here is, express each of the following number as the sum of twin primes. Now it means we have to break 24 is such that it should be the combination, or it should be the addition of two prime numbers, two twin numbers. Like first off we have 24. 24 can be written as 11 plus 13. Simple enough. 36 can be written as 17 plus 19. They should be alternative numbers, we have to remember that. Now 84 can be written as 41 plus 43, and 120 can be written as 59 plus 61. Simple enough. Now sir, what will we do if we just don't remember how to find it? See, there is a very simple trick to find the answer of this. How? Whatever number you are given in the question, suppose we are given 36, okay, and we have to find out the sum of twin primes. Try to get half of this number. Half of this number means 36 by 2, that is 18. Then just the answer will become 17 and 19. Same like in 84 also, half of 84 will become 42. So the answer will become 41 and 43. Simple enough. Now the next question is, check the primality of the following natural numbers. How will we do that, and what do you mean by primality? It means whether these numbers are prime number or not. How to check whether any number is a prime number or not. Now first number we have here is 251. What is the step 1? Find the nearest square. Now if I tell you what is the nearest square number before 251, so before 251 you can say 15 square we have is 225. We cannot take 16 square because 16 square will become more than 251. Okay, like suppose if you take now what will happen? If we take 16 square, 16 square will become 256. 16 square will become 256, but we had to find a square number which is less than 251. So we will be considering 15 square, that is 225. Now what is the next part? Step number 2, you have to find prime numbers. You have to find prime numbers which are less than 15. What are the prime numbers which are less than 15? It are 2, 3, 5, 7, 11 and 13. Now what is the step 3? See, it is very important. Step 3 says, is 251 divisible by any prime number which is found in step 2? Now we have to check that whatever prime numbers we got here, that are 2, 3, 5, 7, 11, 13, is 251 divided by any of these numbers? If it is divisible by this, it means they are not a prime number. You cannot divide 251 by 2, you cannot divide it by 3, 5 no chance, because you need 0 or 5 at the end to divide it by 5. From 7 also you cannot divide, 11 and 13 also you cannot divide 251. Now if you cannot divide, it means no, we cannot divide. It means I can write, if no, then it is a prime number, because you cannot divide 251 by any of these prime numbers of 2, 3, 5, 7, 11 and 13. Now moving to the next question, 323. Again the same thing, we have to find the nearest square. Now see, what is the nearest square we can have? 17 square is 289 and 18 square we have is 324. So we cannot consider 18 square, we have to consider 17 square only, which is 289. Now what will we do? Now we will writing what are the prime numbers. Now we will be writing the prime numbers which are less than 17. What are those? 2, 3, 5, 7, 11, 13, then 17. Less than 17 or equal to 17? Now 2, 3, 5, 7, these all. Now we have to check, is our number 323 divisible by any prime number which is found in step 2? If yes, then it is not a prime number. For your information, now dividing 323 will not be getting divided by 2, we know that. Now 3, 5, 7, 11, 13, I think it will be getting divided by 17, 323. Trying with 17 only, 17 ones are 17, then it will become 153. So 17 nines are 153. So it is getting divided. If it is getting divided, then we can say yes, it is getting divided by 17, therefore it is not a prime number. See, if yes, we know that it is getting completely divided by the number 17, it means it is not a prime number. Simple enough. Now we will solve the next question also like that. For 597, find the nearest square. See, we know that for 25 square is 625, for 24 square is 576. Now for 24, if it is 576, then what will we do? We will say prime numbers less than or equal to 24, because 576 is less than 597 and we had to take that only. So for 24, what are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19 and 23. Now we will check whether 597 is divisible by these or not. See, how will you check? 597 is already there. We know that 600 is divisible by 3. If 600 is divisible by 3, it is just 3 points less, that is 597, and we are dividing by 3 only. So 597 will also be divisible by 3. We can check here. 597 dividing 597 by 3, it will be coming 3 ones are 3, 29, 3 nines are 27, 27, so it will become 199. So yes, we can say, is 597 divisible by any prime number? Yes, it is divisible. It's divisible by 3, therefore it is not a prime number. Simple enough. Now see the next question. Find the nearest square. Now 629. For 629, what will be the square? We have just seen 25 square is 625. It will be the nearest square. Now prime number which are less than 25. Answer will be 2, 3, 5, 7, 11, 13, 17, 19, 23. Now, is 629 divisible by any prime number found in step 2? Yes, say yes, 629 is divisible by 17, therefore it is not a prime number. Now moving forward, 863, how will we solve that? Again the same steps. kindly follow the steps. Now solving 863, we can say that see 30 square, we know that it is 900. So if we take 29 square, it will be 841. Now prime numbers less than or equal to 29, it will be again 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Now, is 863 divisible by any prime number found in the step 2? No, 863 is not divisible by any given prime numbers. Moving to the next question we have here is, now understand, follow all the steps of RSA algo using the following: P is equal to 3, Q is equal to 11, E is equal to 3 to encode the message 9 to some other number and then decode it back. Now these steps with me: P is equal to 3, Q is equal to 11 and E is equal to 3. This is already given in the question. After this, whatever is given in the question, what we have to do? We will be finding values of, find value of n, m and d. What are the formulas for n, m and d? N is equal to pq, m is equal to p minus 1 and q minus 1, and d, we can say d, formula for finding d will be used as de into mod m is equal to 1. Now pq will be 3 into 11, that will be 33. This will be 3 minus 1 is 2, 11 minus 1 is 10, that will become 20. And for de mod m, we can write d as it is, value of e is into 3, mod of value of m is 20, which is equal to 1. Now we can write it as 3d mod m, going at the right hand side, it will become 20 lambda plus 1. Lambda is just any number, natural number. Now moving further, what we have found? We have already found out the value of n, the value of m, and now we will be finding value of d. It will become 3d is equal to 20 plus 1, which is 21. So d will be 21 by 3, that is 7. So this is the values of n, m and d. Now what is the next step? We have to encrypt the number given in the question, which is x, which is given as 9. We have to encrypt the number x is equal to 9, and we will be writing as y is equal to x power e mod n. So y will be 9 power 3 mod 33, y is equal to 729 mod 33, and hence now how will you find this value? You will divide 729 by 33. Whatever the remainder is there, that we have to write here. So I am writing the remainder will be 3. So y is equal to 3. Now after this, what you have to do? See, we have just encrypted the number x, which was 9, into 3. Now decrypting the value for y, which is equal to 3, we already have. Now what we will write here is x is equal to y power d mod n. Now y is 3, d is 7, and mod of n given in the n we have already found out. N is how much? We found out n is 33. Now n is 33. 3 power 7. If you will do 3 power 7, that will be 2187, and dividing by 33, you will get the value of x as 9. Dividing 2187 by 33, then whatever the remainder is there, that we are supposed to write. See, what we are actually doing here is encrypting the number 9 so that it gets converted into another number. Then we are just checking it again that from this formula, from these 3, are we getting the 9 back or not. This is called as encrypting the number, and then we are decrypting the number again. Now moving to the last question we have here is the same as this one. We can follow the same method. Solve the next question. We'll solve the last question, that is p is equal to 5, q is equal to 7, e is equal to 5, and we have to encode the message 11. Now in this case value of x given is 11. Now given p is equal to 5, 7, q is equal to 7, and e is equal to 5. We have to find 3 terms, n, m and d. N is equal to pq, m is equal to p minus 1 and q minus 1, and then we know that de is equal to de mod m is equal to 1. Solving these parts, pq is 5 into 7, that will give me 35. This will give me 5 minus 1 and 7 minus 1, so 4 6 are 24. de, so d as it is, e is given as 5, mod of m is 24 is equal to 1. And then we can write here 5d is equal to 24 lambda plus 1. Lambda you can mention, lambda is nothing but natural number. 5d is equal to 24 plus 1, which is 25, and hence the value of d is 5. Now after this, what we will do, we will encrypt that x and then decrypt that again. Now we have to encrypt x, the value of which is given in question, that is 11, and we know that y is equal to x power e mod of n. Y is equal to 11 power 5 mod n. What do we have here is the value of n we have is 35. Now when we will solve this 11 power 5 and we will divide it by 35, we will get y is equal to 16. Remember, we have to take the remainder. After finding value of y, we will again decrypt the value of y, which is 16, and the formula is x is equal to y power d mod of n. So here 16 power 5 mod of 35. When we will solve it, the remainder we will get is always it should be 11, or the number which we have encrypted. If we get 11, it means our answer is right. If we do not get 11, then it is a problem. It means our answer is wrong. Now this is it for this exercise 1.1. That's all for the day. Thank you so much.